Right, Buddha, let's start the discussion of paper number 8. Question number 1. 1 picometer is equal to 1 picometer. Pico, 10 to the power minus 12 meter should be 1 picometer. But here 10 to the power minus 12 is centimeter now. Therefore, first one is not the correct answer. It should be, let's see, Buddha, we have another value in terms of centimeters here. No? Right, then we can say 10 to the power minus 12 multiplied by 100 gives centimeter value, right? 10 to the power minus 12, and this could be in centimeters for 1 picometer. So it should be 10 to the power here minus 10 centimeters. Is that the correct answer? Then 1 picometer is same as 10 to the power minus 10 centimeters. Correct answer is second one, right? Can you note that one? Question number 2. 3 forces, 9 Newton, 12 Newton, and 15 Newton. Let's see. 3 forces, 9 Newton, 12 Newton, and 15 Newton. Act on a point object in equilibrium. That's very important one. What's that? Equilibrium. The angle between 12 and 15 Newton is. So what should I do? No angles mentioned, no? Each other. We have 3 forces, equilibrium of forces. That only we have 3 forces, but they are not having the angles. Then we have to manage the magnitudes for that. If you are not having the angles with each other, right? If you are not having the angles with each other, you have to manage, yes, the magnitudes like this. How? If you can say 9 squared and 12 squared, the 9 squared is 81 and 12 squared is 144, right? That should be equal to, isn't it, 15 squared? Right, here 5, 225, done. That's it. මෙන්න මේක ඔයා අල්ලගන්න ඕනි point එකක් විදියට. If you can manage it, this is very easy one. Then you can say the arrangement of the forces like this. How? We can say one force is like this. If it is 9, this could be 12, and this should be 15, if so. Isn't it, Pura? Here, 90-degree angle. These other 2 angles are unknown. Then let this one 9. Let this one 12. Here, this one will be the long length one. Right here. This could be 50. පුතාලට මෙන්න මේ configuration එක ඇඳුනා නම් මම හිතනවා ගොඩ කියලා. Then you can say the resultant of these two. Yes, Pute? Resultant of these two. Resultant of 9 Newton and 12 Newton should be this one. This one is the resultant line of these two, 9 Newton and 12 Newton force. You are asked to find this angle, no? That one is equal to 180 minus alpha. This could be the answer. Okay, then alpha we can easily find. Tan alpha equals, what do you say? This one, Q. This is closest angle. This should be P. and this should be Q. So you can say Q divided by P is the resultant. So Q is 9, P is 12. It could be 3 over 4. Then alpha equal tan inverse 3 over 4, right? So correct answer, if this angle is X, X becomes 180 minus tan inverse 3 over 4, isn't it? It should be the answer. Okay, can you catch this one? Not a hard question today, but you have to see the question, right? What a ගාන හොඳට පැහැදිලිව පේන්න ඕන. නොපෙනුනොත් ඔයාට ඕක හදන්න වෙන්නේ නැහැ, right? Okay. Can you complete this one? Okay, question number 3. 13 forces are acted on a point object like that, no? Okay, then the resultant of the system is, right? Can we check this one? Resultant of this one. Okay. You are given the diagram, no? Then, according to the basic arrangement, the only resultant of this one, we can see all the arrows into one direction. So resultant can be noted on this one. Then the line of FA consists with two forces, right? And resultant of this one, arrows are having the same direction, is this one. Now you can avoid this portion and this portion together. And starting from here or anywhere, right, you can see this whole line consists with the forces, and this one consists with two arrows either side. Then if the forces are circulating, then you can say the resultant is 0 of that one. Only rest of the force is B to E. Is that clear, Buddha? B to E is the final thing. Then only present force in between B and E, then correct answer is fifth one. Or you can say like this, no matter. Without considering the whole direction, you can say this one also. How? Okay, starting from here. Let's see. That one and this one completed with each other. So, identical thing. Then outer one cancel, then only available one is BE. Then answer is BE. Okay, right. Question number 4. Following sets of 3 forces are acted on a point object, in which case the resultant cannot be 0. Resultant cannot be 0. This is well-known thing. Resultant of given any 3 forces, right? Resultant cannot have, the resultant cannot be 0. Cannot be 0. එකනේ 4 දෙනෙක් මේක equilibrium එකේ ඉන්නවා. එකෙනෙක් විතරක් never becomes equilibrium. That's what, right? Okay, then we can say, is it like this, Pute? Okay. 2 forces are acting like this. And the other one, it should be like this. And you can say, this force is F1 and F2. Pute, always the resultant of these two should be equal in magnitude to the third force like this, no? If this is the third force, the resultant of these two, let it R1 should be equal in magnitude to F3. Isn't it, Pute? Yes, done. That should be. So, the resultant of these two should be equal in magnitude to third force. This is well-known one. You can do this one. How? Then first thing, you have to find the maximum resultant. R1 max should be F1 plus F2. R1 minimum should be F1 minus F2. Then you have to say third force F3 should be greater or at least equal to minimum resultant. As well, F3 should be smaller or equal to R maximum. I can put the third force එක මෙයාට වඩා වැඩි වෙන්නත් බෑ. එහා පැත්තේ එක්කෙනාට වඩා අඩු වෙන්නත් බෑ. කියන්නේ ඔයා මේකෙන් කැමති forces දෙකක් ගන්න. You can select any two forces, right? You can select any two forces from this one. And then any two. Example, first one, 10 plus 10, maximum resultant is 20 Newton. 10 minus 10, minimum resultant, R max. R minimum is 0 Newton. Then to have the equilibrium, third force should be lied in between these two, including these two too, right? මේ දෙකත් ඇතුළත්ව තුන්වෙනි force එක මේ දෙක අතර මැද්දේ තියෙනවා. තියෙනවනේ පුතා. Then it is definitely obtain the equilibrium. Then out of one is fourth one, right? How? 20යි 10යි 30යි. R max is 30. R minimum is 10. R minimum. Then you can say 40 Newton is greater than the range of this one, right? So correct answer is fourth one. Can you note that one? Again, theory එක පුතාලට මතක තියෙන්න ඕනේ. Theory is this one, right? This should be noted down. අමතක අය පැටලිච්ච අය මෙන්න මේක තමයි ඔයාලගේ summary එක වෙන්න ඕනේ. Right. Take the review. Let's start question number 5. Okay. Question number 5. The body reduces the velocity from 15 ms minus 1 to 7 ms minus 1 by covering 90 meters. Like this. Starting with the velocity 15 ms minus 1. And it obtains velocity 7 ms minus 1. Covering 90 meters, right? Okay. So we can apply v squared equal u squared plus 2as. You can say v squared minus u squared equals 2as, right? So you are given the deceleration is, that's very important one, uniform. Deceleration is uniform, then these two product, 2 into a, we can say they are constant value. Throughout the entire motion, that value doesn't change. Then we can say this one, squared of velocities, difference of squared of velocities, that would be directly proportional to s. පුතාලට මේක එච්චරටම ඔයාලා කැමති නැත්නම් මේ proportional type එකට suit වෙන්න ඔයා කෙලිම මේකටම යන්න. මොකක්ද ලියන්නේ? 15 squared minus 7 squared equals 2 into a into 90 meters. Clear? Okay. And further distance travel before coming to rest. Before coming to rest, 7 from 7 to 0. 2 into a into s. This is number 2. It's better to divide each, Pute. Then 2a cancel. So here we have 15 plus 7. 15 minus 7 divided by 49 equals, it's 90 over s. Done. So the s becomes 25.05 like that, right? Our nearest one is 25 meters. Can you pick the correct answer? This is not exactly simplified one. Definite simplification not available, but round of ones is 25. So correct answer about third one. Right. Can you correct this one? Okay. Can you check question number 6? Okay. Number 6. An elevator is moving upward with a constant speed 10 ms minus 1. Okay. Elevator. This kind of one. Moves with the velocity 10 ms minus 1. ms minus 1. Clear. The man standing in the elevator drops a coin from the height of 2.5 meters. Drops. Put a relative to the elevator. That word is very important. Relative to the elevator, this is dropped. Initial velocity 0. Even though there is a velocity of 10 ms minus 1 for the elevator. You should know, elevator and coin all are having the same velocity towards upward. We have to pick the calculation respect to the elevator. But a relative to the elevator, the coin is dropped. Coin already having the velocity 10 ms minus 1 towards upward with the elevator, and elevator is also consisting the same velocity towards upward. Agreed? Both container and elevator, both the coin and the elevator should have the same velocity as the coin is kept inside the elevator. Then, respect to the elevator, the coin dropped down by 2.5 meters. So, just S equals ut plus half at squared is applied towards downward. It covers by 2.5. ut 0, that is dropped. We have to take this calculation relative to the elevator. It's better to write on here. For coin, relative to the elevator. Now, acceleration, motion under the gravity, t squared. Okay, then 2 here, 5. 2.5 by 5, half is t squared. T becomes 1 over root of 2 seconds, isn't it? Then, correct answer is yes. Second one, right? Okay. Question number 7. A rubber ball is dropped from the height of 5 meters on the planet where the acceleration due to the gravity is not known. Object is dropped from 5 meters. Acceleration under gravity is not given, then let it g. Okay. Fractional loss of velocity. Can we find this velocity when it is hitting on this ground? Yes, we can see how. V squared equal u squared plus 2as. Starting from rest, velocity v1, 2g, h is 5 meter. Let it first one. We don't simplify more. Let it first one. G unknown. Anyhow, motion under the gravity, it turns back with the velocity until the final velocity becomes 0 by 1.8 meters. Again, we are having the same equation, this one, towards upward. Finally comes to 0 velocity. Initially, recoil, rebound velocities, v2 squared. Okay. Minus 2g, h is 1.5, 1.8. Let it second one. Is that clear with that? Okay, then taking this one into the other side, then we have V2 squared equal 2G into 1.8. Let it second one. Then can we divide first and second? Yes, we can. First one, V1 over V2. We have squared value, right? That of squared equal. Here, that side 2G 5 divided by 2G 1.8. So 2G cancel. It becomes 5 over 1.8. මං උඩයි යටයි දෙකම 10න් වැඩි කරගන්න. Multiple by 10. Multiple by 10. Then we have 50 divided by 18, right? Okay, then V2 over V1 equal V2, reciprocal to be considered. V2 over V1 equals, here we have 18 divided by 50, right? And that of square root. This is the ratio of velocity, but they need fractional loss of velocity of the ball on the bouncing. Fractional loss of velocity. Right. Can we write it? Fractional loss of velocity. Fractional loss of velocity V1 minus V2 from V1 multiple by 100. This is percentage loss of velocity. Then here not percentage one, no. Fraction means this one. This is the fraction. So we can say here V1 over V1 minus V2 over V1. So it could be 1 minus V2 over V1. This could be the answer. Those the final answer is 1 minus square root of 18 divided by 50. This should be the final way. Can we copy until here? Fractional loss of velocity. Okay, then the final answer 1 minus 18 over 50, which means 36 over 100, no? 0.36 root, no? It's 1 minus 0.6, right? It could be 0.4. The final answer is making the ratio 0.4, which means 4 by 10, right? It should be like 2 by 5. It should be like 2 by 5. Rearranging the final answer. Better one is first one. Okay. Take your final answer, first answer. Right. Question number 7. Answer is first one, right? Question number 8. Can we check it? Question number 8. A particle moves on a straight line with a constant acceleration, covers 30 meters in the third second, and in the third second. It's complicated one. Why? Initial velocity, does it zero, Buddha? It is not mentioned. Whether the initial velocity is 0 or not, that is not mentioned. So you can't say this is 0, right? And question number 9, you are asked to find Find initial velocity of the above particle, right? 2 consecutive questions, right? Okay, then let's see the diagram. Starting with the initial velocity u, the object covers in the third second. Third second started after completing 2 seconds and ending 3 seconds. It covers 30 meters, right? And rest of third second, clear. Next one. In the fifth second started after completing fourth second and here fifth second. You are given this one is 50 meters. So you can say delta S equal u into delta t plus half into a into delta t square. It make a dane during 2 selected seconds, right? In the same motion while keeping the constant acceleration. Clear? Right. Having the constant acceleration during the selected time interval, we can apply S equal ut plus half at squared twice from here to here and here to here. Subtraction taking this kind of arrangement, right? For that substitution. First here 30. U unknown. Time is 3 minus 2 plus half into acceleration a delta t squared here 3 squared minus 2 squared should be the substitution. Can I have simplification slightly? Anyhow, 30 equals here u plus here half into acceleration a 3 and 2, it should be 5. This should be 5. Let it first one. Same application for the fifth second. 50 equal u into 5 minus 4 plus half into acceleration a. It's 5 squared minus 4 squared like that. Yes, done. Then 50 equals u plus half into a. 5 squared minus 4 squared is 5 plus 4, 9. This should be the second one. Today we can subtract second and first one. Subtracting, it becomes 50 minus 30 equate. You cancel when they're subtracting, clear. It's half 9a minus, we have here, half 5a. I say half is the common factor. It's 20 equal half 9a minus 5a. 20 equals half 9a minus 5a 4a. A becomes 10. ms minus 2. This could be the acceleration. So the correct acceleration, third answer, done. Okay, and we can see acceleration substituted for one of these two first or second equations, it becomes 30 equal u plus half into a10. It's here 5. Pasarappa visipa mehata apuamelo. 5 ms minus 1. That could be the answer for the question number 9. Done. Can we copy? Today, without saying the object remain at rest, you never take u is 0. U is having a certain value, right? Okay. Can we copy this one? Okay. Let's take question number 10. A uniform rod is suspended by using a string which fixed to the midpoint so that it is kept in the equilibrium by placing the rough vertical wall by the angle theta. Coefficient of friction between the rod and the wall is, they need mu, no? Right. අපි diagram එක පොඩ්ඩක් verify කරගමු. It's like this, no? This kind of wall we have. And here we have a rod. According to the question, rod is like this. Here we have string. String is connected to midpoint. That is very important term, Putta, right? String is connected to the midpoint. Can you label the forces acting on the rod? Can you label the forces acting on the rod? Yes, we have. How? First thing, weight of the object. But the weight should be directed at the midpoint as it is uniform rod right here. This is the weight. And this could be the tension. ඔයා මේ ගාන හරියට කිව්වනම් ඔයාට Lami's principle මතක් වෙන්න. What do you say? Here we have a rod. Rod consists with the equilibrium. To have the equilibrium, it needs three forces lied on the same plane and meeting together at a point on the rigid body of the rod. First thing, this is, you are given this one. The rod remain at rest, keeping the equilibrium. First thing. Second thing, if it is kept in the equilibrium, it should have three forces lied on the same plane. ඒක මතක් වුණාද බලන්න ඔයාලට? මතක් වුණා. එහෙමනම් ඔයා මේක ලකුණු කරාද බලන්න. This one should be the third force. R that is needed to keep the equilibrium of the body. If the rod is maintain the equilibrium, that one is the third force that should have to maintain the equilibrium. අහුණාද බලන්න වැඩි. අහුණා, right. එහෙනම් මේක මම R dash කියලා ගන්න. මේ R dash කියන්නේ කවුද? Rod is trying to shifting down, right? The rod is trying to sliding down as this arrangement. පුතේ මේ බර වැටෙද්දි මේක lessන්ද හදන්නේ පල්ලෙහා. Then friction should be operated into this side. The friction should be operated into this side. This should be the direction of friction. Bandika huinawada kiyala. This one is the direction of friction. So, if this is theta, you can say here R dash cos theta. Mana harida kiyala? R dash cos theta represents friction. ඒ කියන්නේ මෙයා කියන්නේ කවුද? R dash වල cos theta component එක. පැහැදිලි? දැන් මතල මතක් කරන්න මොකක්ද? If there is a friction, definitely it needs normal reaction. R. If there is a friction, then මේක නම් පුතේ friction එක මෙති it needs perpendicular reaction. It should have. එහෙනම් වාට පේනවාද R dash cos theta represented normal reaction. ඔය පැත්තකින් ලියනවා මොකක්ද? F equal mu R. F frictional force is R dash cos theta. Mu to be found. Normal reaction represents R dash, sorry, this one, R dash sin theta, right? Angle looking at it, R dash sin theta. Can we correct this one? Sin theta, right? Okay, then R dash sin theta. Now, R dash cancel. Cos theta comes down. Sin theta divided by cos theta. So, this could be tan theta. 1 equal mu tan theta. So, mu becomes 1 over tan theta. That's great question, Putta. excellent one. එතන පොඩ්ඩක් ඔයාගේ technical applications ඔයා දන්න තීරේ මෙතන ඇත්තටම check කරනවා පුතේ points දෙකක්. එකක් about friction. දෙවෙනි එක තමයි about equilibrium of forces, right? ඔයාට මතක් වෙන්න ඕනේ point object maintain at rest. This is the point object. This point object remain at rest under three coplanar forces: tension, R dash, and weight. මේ දෙන්නගේ resultant එක තමයි පුතේ මේ ලකුණු කරලා තියෙන්නේ. හරි? The resultant of this one, resultant of this arrow and this arrow should be labeled as R dash. හදාගෙන ඉවර කරා. Right. Can I have number 11? Okay. බලාගෙන ඉන්න, right? හදද්දී දැන් ඔයගොල්ලෝ මේක හදලානේ තියෙන්නේ. බල ලියන්න නැතුව ඉවර වුණාට පස්සේ ඔක නවත්තලා බලලා ඊට පස්සේ ලියාගෙන යන්න. හරි? Right. Number 11. Number 11. The blocks A and B of mass 0.5 kilogram and 1 kilogram respectively are connected by massless string which goes over the massless smooth pulley as shown in the figure. Okay. Coefficient of dynamic friction between the surfaces 0.25. What is the force F needed to drag the body B towards left with the constant speed? Can you underline constant speed? Constant speed. At the constant speed, there is no acceleration, there is no resultant force. And on right side force should be equal to left side force. Okay, but then when the applied force is made into this side, these two surfaces will have the friction. Can you label it? These two surfaces will have the friction towards write this. Let it F1. පුතාලා මෙයාව මෙහාට අදින්න හදද්දිම මෙතනින් friction එකක් එනවා. Right. Then against that we have tension here T. It is delivered like this, making the tension right here. As this tension, here we have frictional force F. Let it 2. It belongs to the upper object, right? Okay. Then we can say here we have lower object. Here we have upper object, right? Okay. Then forces. Here we have F1. Sorry, applied force F. This is F1. Right? And here we have tension T. Here we have tension T. And frictional force on here, F2. But then this one belongs to the upper object, right? Okay, finding F2. F2 equals mu R. F2 equals mu 0.25 multiplied by R of this one, consisting the weight 0.5, it's 5 Newton, right? Okay, then it should be 5 Newton. Then F2 becomes 1.25 Newton. Keep the answer, right? Okay. Then finding F1 equals mu 0.25. But the normal reaction should be the total normal overall weight. Yes. Overall weight is 1 plus 0.5. 1.5 kilograms should be 50. Like this. F1 becomes 3.75 Newton. What do you say? But the effect of this one, right, is act on the lower body into the opposite direction as the reaction force. Let it F2. This could be F2. For the equilibrium of lower object is considered, then we have F equate to F1 plus TF2 plus T. T is the tension. Tension could be equal to this one as it is maintained constant velocity. Right, පුතේ? Clear. මේ ඔයගොල්ලෝ හදපු හරි පැහැදිලි methods theory questions, right? Okay, then can I have the sum of the forces? F becomes F1 3.75, 1.25 plus another 1.25. Tension should be equal to F2. No, F2 is 1.25. So the answer is 3.75, 254, here 15, 6.25 is the correct answer. Okay, can we pick the correct answer? ගත්තු විදිහ ලියා ගන්න පුතාලා පැටලිච්ච අය. Okay. Okay. Can we check number 12? Okay, number 12. A block of weight 5 Newton is kept at rest on the vertical wall by using 12 Newton. Yes. The force acting on the object by the wall if the block is kept at rest. Underline the block kept at rest. Is it like this? Here we have block and this is the wall, right? These two are contacted, right? Okay, separately we can identify like this. A block of weight 5 Newton. Weight 5 Newton here. And applied force is right here, 12 Newton. The force acting on the object by the wall. So the wall does have two effects. One's weight, right? Once we need weight, right? It has weight, no? Yes, then weight is the one effect to acting on the wall along the surface. Along the surface, it seems like friction. No, it is. R1 here. And another force is operated against the perpendicular 12 Newton like this. Then, මේ පැත්තෙන් 12කින් අපි තෙරපද්දි මෙහාට බිත්තිය. When you apply 12 Newton force towards the wall exerts the force acting on the object against the applied force like this. Then you can see here we have at rest, therefore this is equal to this one. 5 Newton here as well, 12 Newton here. Then resultant should be like this, 13 Newton. Pythagoras, 12 squared plus 5 squared is 13. Correct answer is second one, right? Okay. Take the answer. Okay, දැක්ක ගමන් හුඟක් කියලාවට ළමයි උත්තරයට ගන්නේ 12 Newton. weight එක පොඩ්ඩක් විතර වගේ අමතක වෙලා යනවා. Okay. Number 13. Two objects that are having the horizontal projected angle 60 degree and 30 degree. Okay. 60 degree and 30 degree. Two objects have the same horizontal range. Have the same horizontal range. So if this one is the projectile path, one is having 60 degree angle, the other one is having yes 30 degree angle. Angle 30, angle 60. Okay. Then this velocity and this velocity. What do you say? Same horizontal range. Horizontal range is written to u squared over g sine 2 theta, right? Okay, same horizontal range, S equal, let this one u1, this is u2, right? Okay, then u1 squared over g u1 squared over g sine, first angle is 30, twice of 30. Clear. That is first one. Second thing, same displacement, horizontal range, u2 squared over g, u2 squared over g, sine, twice of 60. Twice of 60, right, Pudha? Then, according to this one, we have 30 into 2, 60, sine 60, root 3 over 2. Sine 2 into 60, sine 120. 120, sine 120, sine 60. Again, these two same, right? It's root 3 over 2. Then, these two same values. Sine 60 and sine 120 same values. GG same, then definitely U1 should be equal to U2. Initial velocities should be same. Is that clear? Initial velocities should be same. Initial velocities should be same. Right, Pute? Then you can say, what's they need? They need the maximum height, the ratio of maximum height. Let this height h1. Let this height h2. Okay. Then we have, for the maximum height, v squared equal u squared plus 2as. Final velocity anyhow at the maximum height 0. This one, u sine theta minus 2gh. Then 2gh equal u sine theta, right? Okay. Then 2gh1 equal u, velocities become same. h1 u sine 30. That of squared, right? The other one, 2gh2 equals u, that's sine 60, no? That of square. Can we divide each? h1 over h2 equate u cancel. Sine 30 half, sine 60 root 3 over 2. 2 goes up, root 3 comes down, that of squared. These two cancel, so h1 over h2 becomes 1/3, which means 30 is to 60, 1/3. Then h2 over h1, angle එක දීලා තියෙන්නේ මේගොල්ලෝ 60 is to 30 කියලා නේ. Yes, 60 is to 30. Then answer is 3 is to 1. Can you take the correct answer? The ratio of maximum height should be third answer, 3 is to 1. Okay. Right, number 14. 14, a uniform rope of length L. Uniform rope of length L, like this. L. Line on the horizontal smooth floor is pulled by the horizontal force of F. Okay, pulled by the horizontal force of F. They need the tension of the rope at the distance of L from the end where the force is applied. Like this. At a point of distance simple L, they need the tension. පුතේ ඔය rope එක කෑලි දෙකකට මෙහෙම කඩන්න. We have well experience about this type of questions, right? Repeated one. This length is L. This one is L minus L. You are asked to find this tension. First thing, we can apply F equal ma for the whole object. At here, you should take mass of the rope is proportional to length L, right? We can take this one directly as the uniform rope, right? Okay. Then F equal ma for whole system for the whole rope to find the acceleration. F is F. Mass is capital L. Acceleration is A. Then A we can say F over L. Then F equal ma is used for the lower one. Last one. Again F equal ma. F is the tension. Mass is L minus L. Acceleration is this one, F over L. Then T becomes F L minus L over L. Then final answer you are given. T equal F. L over L is 1. L over L. This could be the correct answer. Then correct answer is fourth one, right? Okay. Can you note down the correct answer? Fourth one. Right. Can you take number 15? Number 15, a rocket of mass 22 m. Rocket of mass 22 m, right? Rocket of mass 22 m, like this. (22m) is horizontally moving. It's 22 m, weight is 22 mg. But they horizontally moving with a constant velocity. That's the doubt. With the only weight, this is not having the constant velocity. According to the driven figure, there is no constant velocity as only 22 mg. එනම් පුතාලා ගාන කියවද්දිම මතක් වෙන්න ඕනේ මොකද්ද? To maintain the horizontal velocity, equal force with the magnitude of weight should be created upward, right? That should be given by the wings, like that. This is a rocket, a kind of aeroplane, like that. If it is having the wings or any kind of thing, any kind of stuff, right? That should be managed the equal portion as the weight towards opposite direction of the weight. Then hitannako constant velocity is maintained. Then there is no upward velocity, upward acceleration as well, downward acceleration. And towards right side as well, back side. Right side or left side, there is no acceleration. Then there is no any kind of acceleration, which means upward force should be equal to the downward force. Then downward present force should be managed by upward created force by any kind of stuff. Maybe the wings, or maybe the engine, or maybe any kind of rotatable, it's like helicopter, any kind of stuff, it should be managed. එක කොහොමද එන්නේ කොහෙන්ද එන්නේ කියන එක අපිට වැදගත් නැහැ. වැදගත් වෙන්නේ උඩ ෆෝස් එකට යට ඒකට සමාන වෙන්න ඕනේ කියන. පැහැදිලි? දැන් යාලා කියනවා මොකද්ද? The acceleration of the rocket when the bomb of mass 2m. Bomb of mass 2m. Okay. It's like this. Bomb of mass 2 mg. Then put a weight becomes 20 mg, no? But still, the given one, උඩට තිබිච්ච අර 22 mg අඩු වෙන්න බෑ. ඇයි? It is already prepared by using any kind of stuff, right? It is available, but weight is decreasing by 2m. Done. Then put the aeroplane should have acceleration towards upward. How? 22 mg minus 2 mg equal available mass is now 20 m(e). 22 minus 2, 20. Mg equal 20 m(e), like this. 20 mg equal 20 m(e). Then 20, 20 cancel. mm cancel, no? Right. 22 mg minus here 20 mg, no? This one should be 20. It's 2. It's 2 mg equal 20 ma. Then cancel. 20 equal 20. A becomes 1 ms minus 2. This could be the acceleration. මේක හොඳ ගානක් පුතේ දැන්. කොහොමද ඉතින් paper classes වල යන්නේ හොඳ ගණන් තමයි. අර වැඩේ තියෙන විනාඩි 2කට මේක හිතන්න ටිකක් වෙලා මදි අපිට. දැන් මේ වෙන ගොබ්බ ගානක් මේක හදන්න simple calculation. 22 mg minus 20, very small thing, right? It's not a hard case, but we have to think about the situation. If there is a constant velocity, you should know, right? Know any kind of acceleration, anywhere, upward or downward or towards right side or towards left side, no acceleration. That's the only thing, right? Okay. Can we complete it? Number 15 correct answer is fourth one. Okay. Next, number 16. Right. ගානක් විදියට අමාරු නෑ පුතේ. ප්‍රශ්නේ තියෙන understanding is the best thing, right? Okay, number 16. A lift is moving downward with an acceleration 10. The box of mass is placed on the horizontal surface of the lift. It's elevator, right? Lift placing here on the surface upper. Set up is acceleration 10 ms minus 2. Then normal reaction are available, weight available, F equal ma towards downward. We can apply first thing. F downward mg minus r equal m into g. G is the acceleration downward, right? Then r becomes 0. එහෙනම් පුතාලා හොඳටම දන්නවා. F equal mu r. If even though the mu available, r becomes 0, then friction exactly should be 0. Then no need to take the calculation. Motion under the gravity, normal reaction becomes 0. Therefore, frictional force could be 0. Can we make sure the correct answer? Number 16, fourth answer is the correct one. Okay. Right. Take number 17. A vehicle having the mass of 100 kilogram, 1000 kilogram is moving with the uniform velocity of 20 ms minus 1. 20 ms minus 1. This is the vehicle of mass 1000 kilogram moves with the velocity 20 ms minus 1. But the sand is dropped into the rate of 5 kilogram per minute. Sand is dropped. Initial velocity 0. Underline kara. U0. No initial velocity. It is 0. So, into the rate of this one. Mechara pramanikin value at the sand will obtain the momentum. No? For sand, F equal mv minus mu over t. Can we apply it? How? Mass of sand 5 kilogram to obtain 20 from 0 velocity during 60 seconds, 1 minute. 20 of 1 here, 3. Then put it. Sand gains 5 by 3 Newton from the moving vehicle. Our vehicle eකට value ඇටෙද්දී vehicle එකේ speed එක ගන්න value වලට සිද්ධ වෙනවා පුතා මොකද්ද? අන්න take the force of 5 by 3 from the moving vehicle. As the sand is having 0 initial velocity after they have dropped into the cabin, the cabin does have the velocity 20 ms minus 1. That velocity should be obtained by the trolley to take the velocity of the vehicle. And a vehicle and sand now both are moving together. To maintain that velocity, each minute 5 by 3 Newton force should be taken by the vehicle from its engine to maintain the constant velocity. Otherwise, with the weight of the sand, velocity of the vehicle should be dropped down. Then correct answer is fourth one, 5/3. Can we complete it? Right. Okay. Can we check number 19? Number 18. Okay. A block of mass 2 kilogram rests on the block B of mass 8 kilogram rest on the horizontal floor. In the figure, the coefficient of friction between A and B is 0.2, while that the B and the floor is 0.5. Can we find the frictional force acting on B and the lower surface? Force is applied into this side. Can we find the maximum friction? Maximum friction in between B and flow. Finding the maximum friction. Maximum friction of B, F equal mu r, right? Okay. F. Maximum friction is mu 0.5. That when a normal reaction becomes total weight, no? 2 and 8, 10 Newton, 100 Newton. Then normal reaction is 100. Then maximum friction force, 50 Newton. Is that clear? Yes. Then today, to drag the lower object of B, at least we need 50 Newton force instead of 25 Newton. If there is no sliding process of B, there is no friction in between A and B. හරියට නිකන් ලොකු මේසයක් උඩි මකන කෑල්ලක් තියලා මේසෙ තල්ලු කරන්න හදද්දි මේසෙ හෙල්ලෙන්නේවත් නැතුව තියෙනවා නම් උඩ තියෙන මකන කෑල්ලට friction එකක් එන්නේ නැහැ. Such a thing, Buddha. It's very simple. There is an object on the large object, but a force is applied on that large object, but it is not having any kind of feeling to continue the motion. Therefore, no inter-between motion, or there is no relative motion in between A and B. පුතේ AB අතර B පොඩ්ඩක් හරි ගැස්සෙන්න ඕනේ. මොකක් වෙන්නද? Friction එකක් එන්න. To have a friction force in between A and B, the block B should be at least verge of moving. Verge of moving, right? එහෙනම් අඩුම නිව්ටන් 50ක්වත් දෙන්න ඕනේ යටේ එක්කෙනාට උඩේ එක්කෙනාව යන්තම් හරි හොල්ලන්න. Otherwise, there is no friction. So, the answer is, oh yeah, first one, 0. There is no friction. Right? ගත්ත ගමන් හදලා දාන්න එපා. උඩේ එක්කෙනාගේ weight එක 20යි, coefficient එක 0.2යි. 20ව 0.2ක් 4යි නිව්ටන් කියලා උත්තරේ එහෙම මාක් කරන්නේ නැහැ. This is wrong, right? Okay. Let's take the other one. Okay. Okay, can we complete last two questions? 90. The mass string system shown in the figure in the equilibrium of coefficient of friction between A and the table is 0.3. Between the A and the table is 0.3. First of all, Puti, we have to find the maximum frictional force acting on here. Can I have this maximum friction force? How? Maximum friction force, first of all, you should find this one. මං හිතනවා ඔයගොල්ලෝ උත්තරේට සමහර විට ඒක අරන් ඇතිය. F equal ma, sorry, mu r. F maximum friction to be mu 0.3. Normal reaction is 10 Newton. It could be 3 Newton. හරි. Then බැරි වෙලාවත් if the object of A is having the limiting equilibrium, answer should be third one. But the friction is not always this kind of maximum value. මේක maximum එකේ තියෙනවද නැද්ද කියන එක දැන් check කරන්න ඕනේ. How? Today, this tension we can resolve into this side. How? T cos 45. And this tension resolving into this side, T sin 45. පුතාලා හොඳටම දන්නවා මේ magnitudes දෙක සමානයි. ඇයි? Sin 45 and cos 45 both are having the same value. එහෙනම් පුතාලට ලියත හැකි T cos 45 equal T sin 45 as well T sin 45 should be equal to weight of this one 2 Newton ne? Gram deciya කියලා කියන්නේ 0.2 kilogram divided by 1000 and then multiple by 10 it becomes Newton 2. That's it. Maybe එහෙනම් T cos 45 is also 2 Newton. And T cos 45 should be equal to the friction. Isn't it? Frictional force is equal to T cos 45 as well. It is 2 Newton. Done. Then for the frictional force is just 2 Newton. So to maintain the equilibrium, the object doesn't have the maximum frictional force, but the calculation takes place this one. But that is not the correct answer. This one is the present available friction on the system. Therefore, correct answer is 2 Newton. Then බලන්න. වැඩි පැටලුණාද කියන. නෑ පැටලෙන්නේ නෑ ඒක හරි. නමුත් පුතේ අපිව ඇන්දෙන්න පුළුවන් ගණන් හදද්දී අන්ද ගන්නවා කියන එකයි පැටලෙනවා කියන එකයි දෙකක්. හරි. No need, not always applied F equal mu r, right? Sometimes it may have less value than the maximum friction. So we should find that one too. Then answer is third one. Okay, right. What about last one? Can we check it? The rope lies on the table such that the part of it hangs down the table when the length of the hanging part of 1/3 of the entire length. Okay, can we take an idea like this? If this one is the table right here, a rope. Today you are given 1/3 of the part right here, m/3g part is the weight, then put a frictional force should be covered by this one. That. And the normal reaction is maintained by the rest of the weight, 2mg/3. 2/3 one is the normal reaction. So you can say F equal mu r. What do you say? F frictional force mg/3, mu to be found, our normal reaction is 2mg/3. 3 cancel, mg cancel, mu becomes 1 to 0.5. 1, 2 is the second answer. That's the complete discussion of paper number 8. බලන්න දැන් කීයක් හරිද කියලා note කරලා දාගන්න, right? In the next week පුතේ coming week එකේදී ඔයාලට you will have the hard copy of this one. Then you can do again this one, right? Then make a soft copy එක බලාගෙන නේ කරන්න. ආයෙ දවසක ආයෙ අරගෙන කරන්න. මේ හොඳ ප්‍රශ්න පුතාලට මේක හදලා දෙන්නේ නේ. දැන් මේවා extra fee එකක් ගන්න නැතුවනේ මේ classes කරන්නේ ඔයගොල්ලන්ට. Additional workout එකක් විදිහට inside between the 2 consecutive class dates. Then you can do this kind of one. This is for the අපි කියන්නේ personal growth up එකකට මේක කරන්නේ. නිසා මේකේ උපරිම ප්‍රයෝජනය ගන්න හැම දරුවෙක්ම, right? එහෙනම් we'll see with the next normal classes, right? Okay, but the next week we will discuss another 2 structured essays, right? Okay, then goodbye to all of you, right?